Why do we always seek the next great journey? Exploration and adventure are fundamental aspects of human nature. From the earliest migrations to the age of rockets, we've never been content to stay in one place. In the past century, we've reached extreme and incredible destinations like the South Pole, the ocean's depths, and the moon. Now, another monumental journey awaits us. That's the trip from Earth to Mars. Given our adventurous spirit, it's no wonder that Star Trek, a science fiction series that debuted in the 1960s, captured the mainstream consciousness with its depiction of a crew exploring the final frontier in an extraordinary spaceship. While we aren't quite at that level yet, NASA has detailed a plan to land the first humans on Mars and bring them back safely. Here's how they intend to accomplish this incredible feat in what could be described as the modern space race. The first major step in reaching Mars is establishing a permanent presence on the moon. Though it may not seem like it, traveling from the moon to Mars is significantly easier than a direct Earth to Mars trip. Earth's gravity and dense atmosphere make launching large payloads into space challenging. The moon, with its lower gravity and lack of atmosphere, doesn't present these issues, making it an ideal stepping stone for further space exploration. NASA's Artemis program is the key to this strategy. Unlike the Apollo missions, which primarily aim to demonstrate space superiority, the Artemis missions will focus on sustainable living on the moon. Artemis missions 4 through 10 will involve utilizing local resources like water, oxygen, and metals to build infrastructure. Concurrently, NASA and its partners will construct the Lunar Gateway, a space station serving as an outpost in deep space. As NASA establishes a human presence on the moon and in cislunar space, they will also expand robotic exploration on Mars. This includes deploying new rovers and, excitingly, flying machines. The success of the Ingenuity drone has proven that helicopters can operate on Mars, opening new possibilities for exploration and sample collection. NASA even plans to place an autonomous space station in Mars orbit, serving as a way station for missions to and from the Red Planet. A significant part of this plan involves sample return missions, shifting away from one-way trips to Mars. Establishing a foothold on the moon teaches us how to survive and build in a harsh environment, while robotic missions to Mars gather crucial information. This groundwork paves the way for human missions. Before astronauts set foot on Mars, several supply drops will ensure all necessary equipment and resources are in place. This begins with Artemis 10, which will deliver a payload known as Mars Cargo Stage 1 to lunar orbit. Artemis 11 will follow with Mars Cargo Stage 2. These pre-deployed supplies will include everything from return ascent propellant to power sources and mobility equipment. Additionally, an ascent vehicle will be pre-positioned on Mars for the crew's return journey. Artemis 12 marks a major milestone, delivering the Mars 1 human lander with essential surface subsystems and the transit habitat Mars ship to the Lunar Gateway. With these components in place, the stage will be set for humanity's first journey to Mars. NASA plans to use the Gateway Station, orbiting the Moon, as a launch point for its manned missions to Mars. The Gateway will support a crew of 4 for 134 days at a time. From here, a transit habitat carrying the Mars 1 human lander will depart for Mars and likely return to the Gateway. The highlight of this mission will be 2 astronauts landing on Mars in a pressurized vehicle that will serve as both a habitat and a rover. This versatile vehicle will be their home for 30 days, supporting their scientific and exploratory operations. The dual-purpose design is crucial because the crew will need time to recondition their bodies after months of zero-gravity spaceflight. Mars' reduced gravity will make it difficult for them to move immediately, so having a habitation module that also functions as a rover will allow them to begin their mission without delay. To transport the crew from Earth to Mars, NASA is developing a transit habitat using a combination of chemical and electric propulsion stages. This will support a crew of 4 on their journey to Mars and back. While 2 astronauts explore the Martian surface, the remaining 2 will stay in orbit. Landing on Mars presents unique challenges. NASA's recent Perseverance rover landing illustrates the complexity. The rover entered the Martian atmosphere in a capsule, protected by a heat shield due to Mars' thin but present atmosphere. After the initial entry, a giant parachute slowed the descent, and gas thrusters helped the capsule maneuver to a suitable landing site. However, the atmosphere is too thin for the parachute alone to ensure a soft landing. The rover then used a jetpack-like device for a propulsive landing, hovering before being gently lowered to the surface. Similarly, landing a manned vehicle on Mars will be an intense and intricate process. There are two mission profiles for a trip to Mars, a short stay and a long stay. The short stay involves a 217-day journey to Mars, using a gravitational assist from Venus. After a 30-day stay on Mars, the return trip will take 403 days, making the total mission duration 650 days. This option, while lengthy, is considered safer than an extended Mars stay. The long stay mission involves a 210-day direct journey to Mars, with no gravitational assist needed. The crew will remain on Mars for 496 days, requiring extensive planning and pre-deployment. The return trip is shorter, at 210 days, due to an optimal transfer window, resulting in a mission duration of about 916 days. Currently, NASA's plan is based on existing technology, but advancements are on the horizon. NASA and DARPA are collaborating on a new propulsion system that promises faster and more efficient travel. This partnership, known as the Demonstration Rocket for Agile Cislunar Operations, DRACO, aims to develop the first human spacecraft powered by a nuclear thermal rocket engine, significantly outperforming current chemical rocket engines used in space. The nuclear thermal rocket is poised to revolutionize space travel by offering significantly greater efficiency compared to current propulsion methods. This innovative technology is expected to be 3 to 5 times more efficient, leading to faster spacecraft capable of carrying larger payloads, traveling further distances, and maneuvering through space with greater ease. Such advancements could reduce the transit time for a crewed mission to Mars from the current 8 months to as little as 45 days. The benefits of a shorter journey to Mars are considerable. A quicker transit means that astronauts would be exposed to less cosmic radiation, which poses significant health risks. Additionally, shorter travel times reduce the need for extensive supplies like food and water. In space travel, every ounce of mass counts, so decreasing the amount of necessary supplies directly impacts the mission's feasibility and success. The DRACO project, an NTR initiative, is expected to become operational within the next 5 years. This timeline suggests a high level of confidence from the involved agencies that the technology is on track. If everything proceeds as planned, the nuclear engine could be ready in time to build the first Mars Transit Habitat ship, possibly within the next decade. However, it's important to acknowledge that space projects often face delays and setbacks. Despite this, maintaining an optimistic outlook is both fun and motivating. Human history is filled with examples of overcoming challenges through sheer will and determination, and our drive to explore beyond our current limits remains strong. The journey to Mars is a part of our nature, and we are determined to make it happen. Traveling to Mars is a huge challenge, but it's a goal that excites many people. The longest time anyone has spent in space in one go is 437 days. Set by Russian cosmonaut Valery Polyakov, Russian cosmonaut Oleg Kononenko holds the record for the most cumulative time spent in space, with 878 days. A round trip to Mars would take about 3 years, much longer than what astronauts are used to. Human bodies are adapted to life on Earth, which has a unique atmosphere and gravity. Space is very different and quite harsh. Astronauts in space are exposed to dangerous radiation, live in cramped spaces, and have a limited diet. The average stay on the International Space Station, ISS, is around 6 months, and studies show this doesn't harm the body too much. But the long-term effects of space travel are less understood. NASA astronaut Scott Kelly and Russian cosmonaut Mikhail Komienko spent 340 days on the ISS. After returning, Kelly said he felt good, but acknowledged that data might reveal significant changes in his body. A mission to Mars would be even tougher. Astronauts would face 3 main challenges: gravity, radiation, and confinement. they would experience 3 different gravity fields. First, they would be weightless during the 6-month journey to Mars. Once on Mars, they would have to adapt to gravity that's about 1/3 of Earth's. On the way back, they would be weightless again before readjusting to Earth's gravity. Weightlessness affects the body in several ways. Fluids shift in the body. Bones lose calcium and become brittle. Muscles shrink, and cardiovascular fitness declines. Some astronauts even experience vision problems due to pressure on the optic nerve. Mars doesn't have a global magnetic field, exposing astronauts to more space radiation, which can damage cells and cause cancer. The spacecraft going to Mars will need strong radiation protection, and astronauts might have to find extra shielding during solar flares. Living in close quarters with other people for a long time can be stressful and lead to conflicts. However, astronauts often develop effective coping strategies, such as finding quiet time alone. Despite these challenges, NASA is moving forward with plans to send astronauts to Mars. As Scott Kelly said, we need to learn a lot more about human physiology and develop better technology. Exercise, good nutrition, and continuous research are key to surviving long missions in space. Every bit of progress brings us closer to landing on Mars and continuing humanity's tradition of exploration and adventure. So, would you want to be part of the journey to the Red Planet? Let us know in the comments below. Don't forget to subscribe to the channel, and if you want to know more about Mars, watch our videos on alien artifacts on Mars and the Fermi Paradox. See you again. Bye.